Bismillahirrahmanirrahim. Good evening, Usama. If you can hear my voice, please raise your hand. Please raise your hand by clicking here on the icon. Usama, can you hear me? Bismillahirrahmanirrahim. Now, Amir Zaman and Usama, can you hear my voice? Okay, gentlemen, we are going to start our session. If you can see the screen, or you can hear my voice, you can raise your hands in the icon. In other case, you can also type the message in chat box. I welcome all of you here on the board and a very happy Ramadan Kareem. We have limited time to discuss some of the most important topics about introduction to painting and corrosion, the types of corrosion and how to prevent the corrosion. If you have any question, just type in chat or send us an email at info. Please mute your mic. Mute your mic. Okay, I will mute your mic. Okay. Amir raised his hand. Okay, good. So if you have any question, just type in chat or send us the email at info@fatmatvti.org.pk or info@parkkavish.com. You can send us the questions. Inshallah, we will clear all your comments and answer the questions. First, we will cover here what is corrosion and what is the rust. Corrosion is a diffusion controlled process. In other words, we can say that the gradual breakdown of metals through chemical reaction with their environment. This is a complete process. Corrosion is a complete process. And when we define the rust a form of corrosion, but it specially refers to the oxidation of iron or its alloys. So we need to distinguish, or we need to define both these two. What is corrosion and what is rust? You all know that this metals with iron or its alloys in them can cause the rust, as this term specifically refers to the oxidation of iron, either in iron itself or in the steel form, or to the iron oxidized that is produced. The most common cause is prolonged exposure to water. Any metal that contains iron, including steel, will bond with the oxygen atoms found in water to form a layer of iron oxide. This iron oxide is in different colors. I will show you the rust. You can see here different colors. Green also, white also, reddish also. You can see this one. This is fully corroded. When the rust begins, you see this downside, this green, this white, and this reddish color, this brown color. These are the rusts, and these are helpful in the process of corrosion. In the natural phenomena, if we say like only copper and the precious metal gold, silver, platinum are found in nature in their actual metallic state. All other metals, including iron, are processed from minerals or ores into metals which are inherently unstable in their environment. All man-made metals are unstable and have a tendency to revert to their more stable mineral forms. Some metals from protective ceramic films, you can say that this passive films on their surface, and these prevent or slow down this corrosion process. That is why we are also doing the coating and painting. That is also to make it passive, or to make a barrier between the surface and the external environment. Why we are doing all this? To slow down the process of corrosion. Metals corrode because they are used in environments where they are chemically unstable. When the metal is unstable, then this rust and corrosion is going to start. You can see in this slide, here you see all the pipes, pipeline, piping, tanks, structures, even buildings, vessels, each and everything is painted and coated. Why the people they are consuming so much amount of this material, and this also they are wasting the money on this coating and this painting? There is a reason. The reason is the protection. They are protecting this material, this iron, this steel from rust and the process of corrosion. When metal reacts with the external environment and over time can degrade the useful properties or material and structures, including the strength, appearance to liquids and the gases. This deterioration is known as corrosion, means degradation, deterioration. This is called corrosion, and this is a complete process. And the beginning of this process is the rust, the exposure to the environment. The external factors that cause metal to corrode are water, acids, bases, salts, oils, and other solids and liquid chemicals. Metals also corrode when exposed to gaseous materials like acid vapors, ammonia gases, and sulfur, etc. Some materials are resistant to corrosion while some are prone to corrosion. When the material is prone to corrosion, we can prevent them by provide a good sound coating. This includes also painting, plating, galvanizing. By all these things we can protect this steel structure. One more thing I am going to add here, that this training will be continue for next 3-4 days, and if you are eager to go for the exam for BGAS, NAS or SSPC, this training will be very useful for you all guys. See here, this pipeline, piping, even concrete structure is coated. Why we are doing the coating? To protect all this from the deterioration, from destruction. Here the definition of corrosion. Corrosion can be viewed as universal phenomena, omnipresent. Omnipresent means from the first day, ever present. Omnipotent means the most powerful, and supreme means this corrosion process is from the beginning and it's very powerful. We can minimize the consequences of this corrosion. It is therefore everywhere, in the air, in the water, soil, and in environment we encounter. Means we can find in our surroundings this corrosion. It can affect all our structures, our homes, our steel structure, everything. Corrosion is the deterioration or destruction of metal and alloys in the presence of an environment by chemical or electrochemical means. In simple terminology, corrosion processes involves reaction of metal with environmental species. Environmental species, in last few minutes we discussed this one, that what are the external these things. It can be water, acids, base, salts, oils, different types of gases, even temperature. These are the things that can accelerate or that can generate the corrosion process, or it can also make it fast. How fast will a metal corrode? Now the question is, the speed of a corrosion process depends on what? The properties of the material. It depends on the property of the material, how much the strength of a material have, how much the material is strong, it can bear the this corrosion process, and the surrounding environment is very important. Means when we are working outside, we are checking the surroundings, that what kind of climate is there, humid area or this desert area. These are the things that we are encountering to find out the speed of the corrosion. The parameters that are influencing the corrosion speed are atmospheric corrosion. Atmospheric corrosion, these are the things that humidity. If we are in humid area, this corrosion will be called atmospheric corrosion. If it's due to the temperature, concentration of salts, amount of air pollution, including acid rains, dust particles, and this shoots. All these things are the accelerating elements for the atmospheric corrosions. Means due to the atmosphere, this corrosion happens. See this piece of pipe, it's corroded because it's exposed. It's exposed to humidity, exposed to temperature, exposed to salt, exposed to air pollution, exposed to rain, exposed to dust particle. All these things are affecting this piece of pipe. Atmospheric corrosion rate depends on humidity. Corrosion rate depends on humidity. High humidity, more corrosion will occur. If we talk about here in area more humidity area, this Jubail area, the most humid area in the kingdom. So we are doing the our best protection for our structures, for our tanks, for our piping system. Why we are doing all this? Because this is high humidity area, and we are protecting our this assets, our structures. So these are the factors that are accelerating the atmospheric corrosion. This is humidity, high humidity, atmospheric corrosion. Now we are going the types of corrosion. What are the types of the corrosion? The types of the corrosion are uniform corrosion, galvanic corrosion, pitting, atmospheric corrosion. Just now we discussed this one, atmospheric corrosion. Corrosion, fretting, corrosive corrosion, cavitation, stress corrosion. Stress corrosion is also known as intergranular and transgranular corrosion, hydrogen cracking, and embrittlement corrosion fatigue. So any name, all the goes to stress corrosion. We are going to start one by one to discuss the types of corrosion. Now this is the picture. This is uniform corrosion. You can see here the full surface is covered and in the uniform way. Uniform corrosion is a very common form found in ferrous metals and alloys that are not protected by surface coating or inhibitors. Means if any surface, any steel, we are not going to coat that one, you can found uniform corrosion on that surface because that surface will be fully covered by first rust, and then this rust will accelerate the process of corrosion. A uniform layer of rust on the surface is formed when exposed to corrosive environments. Atmospheric corrosion is a typical example of this because when most of the time you are experiencing that when any bare metal, any steel pipe, any steel bar, when you are keeping outside in the sunlight, if this piece of pipe, this piece of bar, this piece of sheet will stay outside for 2 to 3 days in day and night. After 3 4 days, you can find a thin layer of powder formed. That is, this is the rust in reddish color, in brown color, in yellowish color. You can easily found on the full body of that piece or whatever it is, pipe or sheet or. So it means that the full surface will be covered in this form of the corrosion, uniform corrosion. And it happens why? Due to the atmosphere, due to the air, due to the water, due to the humidity, due to the high temperature. These all things are affecting our atmospheric corrosion, and this is also a typical example of the uniform corrosion is also, you can say, atmospheric corrosion. Now what is galvanic corrosion? You can also say that this one bimetallic corrosion, mean two dissimilar items come together in contact, means SS and CS, stainless steel and carbon steel, when come together, joined together, this galvanic corrosion will occur. Galvanic corrosion, often referred to as dissimilar metal corrosion, occur in galvanic couples where the active one corrodes. In our next chapters or next exercises, where we will learn about this, what is active and what is passive, these metals. So you will learn easily about this one. Now what is pitting corrosion, or how we discuss this pitting corrosion? Pitting corrosion is localized phenomena confined to smaller areas. Formation of micro pits can be very damaging. Pitting factors ratio of deepest pit to average penetration can be used to evaluate severity of pitting corrosion, which is usually observed in passive metal and alloys. Most of the time in our daily experience during the blasting, the people who are involved in this painting and coating field, they know it well that when we are doing the blasting, after blasting, when we are checking the surface of the profile, if we found any pitting, in some cases we are also rejecting the material. We are not going to paint that material due to the pitting, because this pitting is very critical and very dangerous for the next process. So during the pressurization, during the water hydro test, or this any kind of pressure testing, so any problem or anything can happen. So due to this one, we are going for NDT for this process. If we found any pitting after the blasting, if we see with the naked eye, we are not accepting the material. Why we are not accepting? Because it is critical. I don't know how much depth this pitting have, up to where already the pipe is corroded. So the depth, the criticality, everything we are measuring through the NDT, non-destructive testings. If the report is okay, then only we proceed for the next process. After blasting, we are going for the painting. Otherwise, we will keep the pipe idle. We will not go for the painting. So pitting corrosion is a localized phenomenon. Means in smaller area, in small space, this pitting corrosion will occur. Most of the time this pitting corrosion on the pipes also, maybe the pipes are outside in the exposed in the sunlight or to the atmosphere, maybe this pitting will come on the surface. But most of the time when the tank sheets, if they are uh, outside to the atmosphere, so we are facing the problems. Such kind of pittings we can easily found after the blasting. When we are doing the blasting, after blasting, through visual, without any inspection aids, only visual naked eye, we can identify this corrosion pitting on the surface, If we found any pitting after the blasting, we found this pitting, then we hold that pipe, we hold that structure for further investigation, and for further investigation is the NDT testing. And after the NDT test, if it is okay, then we are proceeding for the next step for the primer, intermediate, top coat, whatever we are going to do. So Zaid Anwar, he joined us now. Welcome, Zaid. Now the next type of corrosion is this fretting corrosion. Fretting corrosion means when two materials or two items or two things of the same nature or maybe the different, when we are rubbing them together and the surface breaks from inside or outside, that area starts corrosion, rust, pitting, reddish color, yellowish color. This all depends on the surrounding atmosphere. Means if it is humid area, maybe you will find some different color. If this is dry area, you will find something different, but the surface will be corroded. Corrosion occurring at contact regions between materials under load, subjected to slip and vibration, can be termed fretting. I think this is, here we can see this bearing, this one, where it is fixed, and its external body where it is hitting or rubbing or in direct contact, this area. So here we can see this area inside, internal ring rust, here external rust, because this area is in direct contact with the surface of this material. So when rubbing or loading or stressing this area, here this fretting corrosion started. So what next? So these are the things we discussed, that what are the types of corrosion: uniform corrosion, galvanic corrosion, pitting, atmospheric corrosion, erosion corrosion. What is erosion corrosion? The best example you can see here, if someone know about the tape, this whatever in Urdu we say this नलका, अगर ये पानी का नलका किसी ने खोल के देखा है ना, उसके बिल्कुल एज पे जहां से पानी जो है वो निकल रहा है बाहर, वो एरिया जो है आपका बिल्कुल पतला हो जाता है. That is called erosion. This is the best example of the erosion. Erosion corrosion due to the pressure. If we lost something, that is erosion. Pitting corrosion, fretting, and now the question is, if we have the corrosion, if we have the rust, how we will protect, how we will prevent, how we will reduce this corrosion. This is the important thing. If we check the budgets of the refineries, of the plants, of the piping projects, if we check all the budgets, the most of the budget will be for the coating, for the painting. Why? Because this painting and coating is giving the life to this plant, this structure, this refinery. That is why the management is spending too much money on painting and coating. Now how we can prevent? Improve the construction. Our design should be good, our position should be good. Now what is the meaning of design or this position? Means sometimes if we are using some pipe, some structure, suppose I am going to use a structure beam, and making the piping structure. And I have the beam. This is U shape. I am using this U shape beams in making the structure. When there is rain, when there is sandstorm, all the sand, all the water will accumulated on top of this beam, which is in U shape. This is the design U shape. Now this is the design mistake, that why you are using this U shape column, U shape beam, where the water can stay there, the sand can accumulate there. So these are the things that we need to check and identify during our inspections, that whether this design is applicable, or this design is supportive to protect this structure, to protect this refinery, to protect this plant from the corrosion, from the rust, or what are the elements that can accelerate the rust, the corrosion. So how we can prevent? By design and by changing the position. Then what next? Make the optimal selection of the material. Most of the time the companies, they are selecting cheap material. Maybe I give them money to use something good, something in good quality, and they are going in the market and they are purchasing some low alloy steel, and they are using this one. When they will use low quality material, we cannot stop the corrosion, because that thing is low quality material and it will be corroded soon. And number third, the use of corrosion protection. Now how, or what are the things that we are using for corrosion protection? The things we are using for corrosion protection are the paint, the rubber or plastic, the anodic protection, cathodic protection, metallic coating, galvanizing, corrosion resistance coating. So different types of coating and painting or insulation we are using to protect our steel, to protect our structure, to protect our this items. We are using all these materials, paint. So these are the different things that we are using from the prevention of corrosion. We are using this one. How we can change the environment? We are using inhabitants. Most of the time we can say that uh, ultraviolet rays protection paint. We are using the paint. We are using the paint for this. Arsalan, you question this painting in coating. I will reply you in email, or if I have time, I will discuss here. All of you, if you have any questions, just type in the chat column or send an email. So changing the environment. How we can change the environment? We can remove the oxygen from the atmosphere. It is very not possible. But we can make any barrier between oxygen and the pipe, the structure, the tank, reduce water flow velocity, change the pH. If anything which is more acidic, the corrosion will be more. And change in temperature, high temperature, high corrosion rate, and reduce relative humidity. In the first 2-3 slides, we study here that this reduce in humidity. can change the order for this for reducing the corrosion. If high humidity, high corrosion. So these are the things that we are doing or we are applying for what? To prevent or to reduce the corrosion. Apart from using paint and cathodic protection CP, how to protect against corrosion? How we can protect the things? Corrosion protection can be achieved in many ways. In many ways we can protect our structures. How? Good design. We discussed here earlier that good design is very important in the protection. If our design is good, we can minimize the chances of corrosion. Avoid corrosion traps. What are the traps? We can avoid corrosion. Improved accessibility maintenance. If we are doing surveillance, if we are doing inspections, if we are checking the things keenly and monitoring every day, and if we found any pipe, any structure damage or any scratches, so immediately if we are doing this touch up or we are doing the maintenance, so we can avoid. Proper material selection. If the base material means the piping is low quality grade, so in this case even you are applying a good quality of paint, you cannot do anything. Again, this issue will be passive and more active material will come here, because on the top side the top layer is very strong, that is paint, and under the paint the pipe is low quality, so the corrosion will start from internal side, inside, because your outside is more strong than the inner side. So if the material is not good, the pipe is not good, the sheet is not good, and you applied a very good quality of paint on top side, how when you see top side, how it's very good, it's looking good, but the corrosion reaction will start from the inside. So that is why the inner material what we are using for the piping is should be good quality. The next thing, the insulation. Insulate between dissimilar material. If we are applying two types of material, suppose we are using stainless steel and we are using carbon steel, so we need to avoid to touch these two materials directly. We need to apply some insulation in between these two, the carbon steel and the SS material, and change the surrounding environment. In most of the cases, the person who is involved in this painting field, they knows that sometimes when we are applying the painting we need some more humidity. So what we are doing, if the atmospheric humidity is not good, is not applicable, and it means we have low rate of humidity, what we are doing, we are changing the surrounding environment by applying water in the surrounding. We are bringing one truck and we are sprinkling this water all around to make the area, to make the surrounding humid, to fulfill the requirement. Zinc rich inorganic zinc APCS 17A, when we are applying on the pipes we need humidity more than 50. So if we have low humidity, we can change. This is the change of environment. But natural environment, this natural phenomena, we cannot change this one. Remove water and humidity by applying this dehumidifier and means external things, uh, extra machinery to minimize these things, this humidity, and this is most costly. Apply metallic coatings. Metallic coatings, you can see all this electrical poles, these are galvanized, all the structures galvanized, all the handrail galvanized, all the gratings galvanized. So this is metallic coating. Why we are doing this one? For the long life, for the protection. Use corrosion inhibitors closed system. In our painting, when we are designing any paint system, any painting material, we are giving our specification to the manufacturer that we need this type of paint, we need this type of paint, we need protection from this, we need protection from the sunlight, we need protection from the ultraviolet rays, we need protection from the humidity, we need protection from the cold or water vapors, we need protection from the acids and alkalis. So these are the things we need to discuss with the manufacturer. Then manufacturer will give us the painting detail, the specification that this painting material is ideal for your plant, you can use this painting material. So these are the things that we need to check and encounter and monitor, uh, to protect the things from the corrosion. So this surface preparation and pre-treatment, this is our next topic, and inshallah this topic will be covered in our tomorrow's class, tomorrow session. And you need to register for the next session also as well, because each and every class have the unique ID, but this course is ongoing in the continuity. It will be helpful for you to appearing in the BGAS and for NAS or for SSPC, so it will be helpful. So in our today class we discuss the things that what is corrosion, what are the types of corrosion. We started from the corrosion, then what is corrosion and how it is coming. Corrosion is a complete comprehensive process, and rust is the main thing that can accelerate the process of corrosion. Basically this corrosion starts from the rust. Rust is a thin layer which makes this layer in white color or green color or reddish color. After that, the corrosion process will start immediately and it's going to accelerate. These plants, these piping systems, this concrete structures, piping, everything we are doing the painting for the protection. All these things. Then we define the corrosion. What is corrosion? Deterioration, destruction of the material, presence of environment, chemical, all these things. What are the things that are helping in corrosion, in accelerating? How a metal corrode fast? What are the things? What are the important things? After that, we discussed what is atmospheric corrosion and how it's accelerating, how it's speed up. This is humidity, temperature, concentration, salts, pollution. All these things are under the weather conditions, covering the weathers, atmosphere. Then corrosion repair, this rate depends on the humidity. Corrosion rate depends on humidity, high corrosion. If high humidity, high corrosion. Low humidity will be helpful to reduce the rate of the corrosion. Later on, we discuss the types of the corrosion: uniform, galvanic, pitting, atmospheric corrosion, fretting, corrosive corrosion, cavities, stress corrosion. Uniform corrosion, then galvanic corrosion, also known as bimetallic corrosion, then pitting, fretting corrosion, and the protection. How we are protecting the things from the corrosion. This is the important things. These are the things. So now we are going to the questions. What are the questions? Arsalan, what is difference between painting and coating? Other than our profession, now I belong to a coating painting profession. If I'm not, I'm an ordinary person. If ordinary speaking, when somebody is talking about the painting, or or if someone is asking what kind of job you are doing or what kind of work you are doing, I will say, okay, painting. Oh, they will think, oh, this painting means they are feeling pity for us, that these people, they are working for the painting, they don't have any other jobs. So this painting concept is very different in our this ordinary people who are who don't have the awareness or this knowledge of the painting. In our daily life or natural, we can say, what is painting? Painting means we are also doing the painting in our arts group. That is also called painting. But if we are going to distinguish what is painting and coating, coating is a broad term in which we are using approved material for the protection. Means we are using APCS 1B, this is coating. We are using 113C, this is coating. We are doing the coating, approved material for the protection. And in the same thing, when we are going to change the texture of anything, we are suppose we are going to do some color coding, that thing we are doing the painting. When we are doing painting, our main target is the appearance. We are going to change the appearance. But in coating, appearance doesn't matter. Our main source, our main target is the protection, that we need to do the protection for this material. We need to protect. You can see this galvanizing. When we are doing the galvanizing, this is coating. When we are applying the tape wrapping, when we are applying the canosa, all these things comes under coating. And all the color codes only just covering for the texture, these things are painting. So painting is in scope is the limited one, and coating is the broad sense. Also, please Salam, send me the email. I will reply in the mail. If you have any other question, you have 10 minutes, you can ask. And for tomorrow, you need to register for this other session as well. I already shared the link on the Facebook, also on the WhatsApp also. So if anyone who don't have this link, share the email address, so I will send you. So no more questions? Okay, gentlemen, thank you very much for attending this session. And if you have any difficulty or any questions, you can drop an email, info@parkavish.com, or info@atmatvt.org.pk. And thank you very much for attending this session. And now we are going to close this session. I think you enjoyed it well. Thank you so much. Ahmed Zaman. Fretting and stress. This is the fretting. Fretting means when we are going to rub anything. When we are putting load, means this is also stress, but it's rubbing. The thing, it's rubbing each other. Just when you are touching your putting your hands together, when you are rubbing in this condition, and yeah, both are under the stress. But stress is also the load. When you are putting the load, that is also stress. When you are putting the load to someone, and the downside, the strength is less or weak, so the shape of the thing will change. Amir, you got my point? Okay, when we are rubbing, this is called the fretting. And if we are putting the load downside and top side and layer by layer, that is also stress, the load. Here you can see under load subjected to slip. The thing, something is slipping, something is missing, something is rubbing. Continuous, something is vibrating. So that change is this fretting corrosion. And when we are putting the stress here, in last here, when I said, see what is stress corrosion, here we see stress corrosion, intergranular and transgranular corrosion, hydrogen cracking, or embrittlement corrosion fatigue. Means when we are putting load on something, the inner structure of the thing is going to change, and the shape will change. Maybe I have something round. When I put the load on that thing, that will be pressed down and break and crack. Okay, thank you so much. I think you all have enjoyed it, huh? Thank you very much, and good night. Tomorrow I will answer you this question, huh? For today, good night. Thank you so much.